This is Numerical Methods and section 13.2, and it's called Improving on a Root. So we want to zone in and try and find smaller intervals and find better approximations for our root. And the first method, I'm going to call this method 1, is called interval bisection. This method uses an interval containing a root, so they give you the interval to find a smaller interval. As its name suggests, the interval is cut in half, hence the bisection, after each iteration. An iteration is a process with an input and an output, which is repeated time and time again. The input at each stage is the output from the previous stage. So let's have a look at the first example. They've given you a diagram, a sketch of the curve. They don't need to do that. But the first thing they ask for you to do is to verify that a root of the equation 2 to the power of x minus 11 minus 5x equals 0 lies in the interval between 5 and 5.8. So they've asked you to verify the root, and you do that using the change of sign rule. And so the equation already equals to 0. All we have to do is to substitute the value of the x values of the interval. So x is 5 and x is 5.8. And for the first part, that means the following. It means I'm going to say 2 to the power of 5 minus 11 minus 5 times 5. And that's going to give me negative 4 once you put it on your calculator. Let's see. So 2 to the power of 5, you're using this button. And then minus 11 minus 5 times 5, and it gives minus 4. And that is a number smaller than 0, it's negative. And then I've got 2 to the power of 5.8 minus 11 minus 5 times 5.8, and you're going to get 15.7, and that is a positive number, obviously bigger than 0, and so you're going to put your conclusion, change of sign. Therefore, the root lies in the interval x is bigger than 5, smaller than 5.8. So first thing, nothing, no change from section 13.1. Right, part B or part 2. Use interval bisection. So they definitely tell you which method they want you to use. Use interval bisection to find an interval with width 0.1 that contains the root. Now, what does this mean? The interval from 5 to 5.8 has a width of 0.8. Okay, they want your interval to have a width of 0.1. So let's say 5 and 5.1, or 5.1 and 5.2. That's what they want. So they're trying to get to a much smaller interval, and they told you what they want. So that is the interval width. So the first thing you're going to do is to find the original width of the interval, or the original interval's width. So that's 5.8 minus 5, which is 0.8. You get that width and you bisect it, you halve it. So half the interval width. So 0.8 divided by 2 is 0.4. And that's the width that I'm going to start with. I'm going to try from 5, so I always start with the first number in the interval, but I'm not going to go to 5.8, I'm going to go to 5.4. And I'm going to substitute in my values and into the equation, the same equation, so that's 2 to the power of x minus 11, and it was minus 5. And I know that this is going to give me negative 4 because I've already looked at it. That's smaller than 0. And then I'm going to look at 5.4, and when I substitute it in again the original equation, I get 4.2, which is bigger than 0. So my conclusion, there's a change of sign, therefore there's a root in that interval. But I'm not done yet, because that interval has a width of 0.4. I want a width of 0.1. So I need to try again. I get 0.4, that interval, and I halve it again, and it gives me 0.2. And I start from the first value of x, and I go to 5.2, and I substitute that into the equation. So I know this is minus 4, I've found it before, and I substitute that in, 5.2, I put that into my calculator, and I get negative 2. They're both negative, so no change of sign. Possibly no root. So I need to take a different combination that has the same width. I know that there is a root from 5 to 5.4, so I can play around with that. I can go from, for example, 5.2 to 5.4, and you have to try different values. I could have gone from 5.1 to 5.3, could have done that. So I've got 5.2, which I know gives me negative 2, smaller than 0. And I'll put 5.4, which I've also calculated previously, 4.2. So that's bigger than 0. So that's a change of sign. Therefore, root lies in that interval. I haven't finished yet though, because that interval is a 0.2 width and I want a 0.1. So I need to get this interval 0.2, half it again, I get my 0.1, and I go from 5.2, I start with 5.2 because that was my starting point there, and I'm going to go 5.3, and I'm going to substitute it in. So 5.2 I know already is negative 2, and I need to substitute 5.3 into the equation. And just remind us, I have got my notes, I already know, but you should be working with your calculator. 2 to the power of 5.3 minus 11, and it was minus 5 times 5.3, and that gives me 1.9, which is bigger than 0. Therefore, there's a change of sign, Therefore, there's a root in the interval x is bigger than 5.2 and 5.3. And that's the interval we want, and it's of course to 1 decimal place. So the 0.1 meant not just the width, but it's to 1 decimal place as well. Okay, so that's the first method, the interval bisection, and the second method is called decimal search. So that's another way of improving the root that was already found. So this method systematically increases the number of significant figures to which the root can be given. That's what it means. So the first question says, verify that a root of x cubed minus x minus 1 equals 0 lies in the interval 1 to 2. So the equation already equals to 0, so I'm going to substitute the value of 1. So 1 cubed minus 1, which equals minus 1, and that's smaller to 0. And then I'm going to substitute the value of 2, so that's 2 cubed minus 2 minus 1, which is 5, and we've got a change of sign. Therefore, there's a root in the interval x is bigger than 1 and smaller than 2. So we verified it. And the second question says, use a decimal search to find a root with the interval of width 0.001. So that is 3 decimal places. And again, they have told you what method to use. Use decimal search. Now, to be able to do this, you need to start with 1 decimal place intervals and then increase your intervals. So start with 1 decimal place and you're going to be increasing. So my interval is from 1 to 2. So looking for the decimal intervals, I'm going to start by substituting 1.1. That's the first kind of decimal number bigger than 1 is 1.1. So I substitute that in. So remember, you should be using your calculator. Here's my equation. So I'm going to put 1.1 cubed minus 1.1 minus 1, and I find the answer. And to be honest, it doesn't matter whether you round it, whether minus 0.8 is fine, because what I'm interested in is whether it's bigger than or smaller than 0. I'm interested in the sign. So negative 0.8 smaller than 0. Then I'm searching for when it is going to change. So I substitute 1.2, and you take it 1 decimal at a time. You don't skip anything because you literally want to know when it will change. I put that into the equation and it gives me minus 0.5, no change. I substitute 1.3 and it gives me minus 0.1, again no change in sign, they're all negative numbers. 1.4 and it gives me 0.3. So there is a change of sign between 1.3 and 1.4. So that is going to be our interval, new interval. So our new interval is x is bigger than 1.3 and smaller than 1.4. And now I can try to 2 decimal places. So I'm going to substitute 1.31. That's the first number bigger than 1.3. And I substitute that into the equation and I get 0.06, which is smaller than 0. And the next number up, 1.32. And I get minus 0.02, again smaller than 0. And then I try 1.33, all substituting it into the equation using my calculator, and I get 0.02. Now there's a change in sign, which means that there's an interval between 1.32 and 1.33. So new interval. So I've got 1.32, x is bigger than 1.32 and smaller than 1.33. So I'm now going to try numbers to 3 decimal places. So the first number bigger than 1.32 is 1.321. And I substitute that into the equation and I get 0.002, negative 0.02, which is smaller than 0. The next number is 1.322, and that's also a negative number. And I'm trying again, 1.323, and that also gives me a negative number. So I keep trying. 1.324 minus 0.003, still negative, and I keep trying. 1.325, and that gives me 0.001, which is bigger than 0, which means that my new interval so I'm zoning in on the root. So change of sign. Therefore, there's a root in the interval. X is bigger than 1.324 and smaller than 1.325. And finally, if I bring the question up a bit, it says write down the root to 2 decimal places. So here's my interval. If I round to 2 decimal places, I'm going to have x is 1.32. It's not going to be this, because if I round this to 2 decimal places, I get 1.33, but 1.33 is not smaller than, it's bigger than 1.325, so it doesn't actually fit into my interval. So the root, the answer is 1.32, and I'm going to say it can't be 1.33, as that's not in the interval. That's not smaller than 1.325. So it must be 1.32 and not 1.33. And that's the end of section 13.2.